In this video, we are going to add two more functions into our library of functions that we have graphed. The first one is the square root of x, and the second one is the cube root of x. So let's start off with square root. So what I'm going to do is I'm going to graph that by plotting some points so you can see where the graph comes from. I'm going to start right here with 0. So when I substitute in 0 for x, square root of 0 is 0. All right, and then I'm going to choose to do 1. 1 is a perfect square number. Square root of 1 is 1, so I'm going to put a dot there. My next perfect square number is 4. And I'm not saying these numbers don't have square roots, it's just that perfect square numbers are easier to graph. So my next perfect square integer here is 4. Square root of 4 is 2. Moving across, my next perfect square integer is going to be right here at 9. Square root of 9 is 3. And then my next perfect square integer would be at 16, which you cannot see. So I'm going to stop at this point and I'm going to connect the dots. Nice smooth curve going off forever here to the right because I continue finding more and more square roots as I go. Okay, let's look at what happens over here on the left-hand side of 0. Well, if I try to substitute in -1, I get the square root of -1, which you will remember from before is I, right? Square root of -1 is I. It's imaginary. So I cannot graph imaginary numbers on my real axes, and so I cannot put any points on this side. Any number that I select on the left-hand side of 0 will end up being imaginary because they're all negative numbers. So this is my graph for y equals the square root of x. Okay, let's look at domain and range. So domain, you remember, is left to right, the x values from smallest to biggest. So the smallest that this particular graph gets is 0. The largest, well, this arrow tells me it's going on and on forever to the right. So the largest is infinity. Okay, so at infinity, I'm going to put a parentheses. We always put parentheses on infinity because it's never included. How about 0? Should I include 0 or not include 0 in my graph? Well, I'm going to include it, so I'm going to put a bracket. And the reason why it's included is because the square root of 0 is 0. That exists. And so therefore it is part of the domain. All right, let's look at range. You guys remember range is bottom to top. So what is the lowest that this graph goes? Well, the lowest it goes is 0. And just like with the domain, that 0 is going to be included because I do actually reach the point 0, 0. The square root of 0 is 0. And as I move up, this arrow over here is telling me that as I move to the right, I'm also moving up. So the range will be going toward infinity. So this graph grows as you go to the right. It's not growing very quickly. It's actually a very slow growing graph, but it is going up as you move to the right. All right, let's do x and y intercepts. All right, you remember that x-intercept has lots of synonyms. The x-intercepts are the roots. The x-intercepts are the solutions when it's equal to 0. The x-intercepts are called zeros. So in this case, we're going to look at the fact that I can substitute 0 for y, and I can find the solution to this equation. So the inverse of square root, is square. Let's square both sides. Square root and square root cancel each other out, and I get x equals 0. So that means when my y value is 0, my x value is 0 as well. And so my x-intercept is the origin. And remember we said in a different video, when your x-intercept is the origin, your y-intercept is the origin as well. So I'm going to get the point 0, 0 for both the x and the y-intercept. All right, let's look at intervals of positive and negative. Okay, so remind yourself of what that means. What does it mean for a graph to be positive? Right, it means the graph is going to be above the x-axis. So I'm going to color the part blue that's above the x-axis. I remember that I have an arrow here. And then I'm going to color the part red that's negative. So what does negative mean? Well, it's the opposite of positive. So if positive is above the x-axis, negative must mean below the x-axis. And so I have nothing here that I need to color red. Okay, so what is my interval for positive? So I'm going to get 0 to infinity. It's the whole thing. All right, so this is a little bit tricky though. Look at 0, 0. at the x value of 0, is the y value positive? Is the y value above 0? Well, no, it's not. The y value of 0 is 0, so that is not included. So even though it is included in the domain, it is not included in the intervals where where the y is positive. So does that mean that it's included in the part where it's negative? Well, no, because 0 itself is neither positive nor negative, so I do not have an interval where this graph is negative. It is positive on its whole domain, except actually at the point 0, where it is neither positive nor negative. All right, intervals of increasing and decreasing. So let's color in gray where this one is increasing. All right, and what does increasing mean? Well, increasing means it's going up. And remember, you always read the graph from left to right. So as I move from left to right, I'm going to color in gray the parts where it is going up, parts where it is increasing, which is going to be all of this, including that arrow. Now, what am I going to color orange? Where is this one decreasing? Where is it going down? Well, it's not going down at all. It's always going up. So therefore, I will not color anything orange. And just like before, that 0 is not going to actually be included. So it is increasing from 0 to infinity. And then just like before, we're decreasing. I need to make sure I put that I know it's not decreasing anywhere. There are no intervals where this one is decreasing. All right, so I want you to look at something. This is the parabola. This is the graph of y equals x squared that we already talked about. And here's the positive square root of x that we already looked at. Here's the negative square root of x, right? If I multiply all those numbers by a negative, I should get a negative answer. So here's the negative square root of x. And what do you notice about this one and this one? Well, the square root of x, the positive negative square root of x, is really just this one turned on its side. And in fact, if we look at the two of them graphed together, the green one here being my parabola, y equals x squared, the red one, here's the positive square root of x, here's the negative square root of x, and the red one is actually a mirror image of the green one if I let my mirror be diagonal right here on y equals x. So if I were to take the mirror image of this part, you see I would get this piece. They cross on the mirror. This green part mirrors to this red part, and this green part over here mirrors to this red part. So hopefully that'll help you remember the shape, that it is a mirror image of y equals x squared. In our next unit, we'll look at why that is, and we'll talk about it a lot more, but I just thought that might help you remember the shape because you've been doing y equals x squared for a couple years, and so hopefully that'll help you remember this shape right here for y equals the square root of x, because it's a mirror image of the other one. Okay, now let's look at cube root of x. We're going to do the same thing. We're going to start off by plotting some points. So the cube root of 0 is 0. The cube root of 1 is 1. All right, now what's our next perfect cube number? Well, 2 times 2 times 2 is 8. So cube root of 8 right here is going to be 2. And our next perfect cube number is 27, which I cannot see on my graph. So I'm going to choose to stop right there. And I'm going to connect the dots in a nice smooth curve, going on and on forever to the right because I can keep taking cube roots as far as I want. All right, so now let's look at the negative side. Well, you remember you can take the cube root of a negative in the reals because negative times negative times negative will just be negative. So if I have a negative on the inside of my cube root, that just means my answer is negative. So the cube root of negative 1 is negative 1. Cube root of negative 8 would be negative 2. That'd be way over here somewhere. And so I can connect the dots this way as well. So that should look a lot smoother. Let me see if I can draw that all as one thing and make it look a lot smoother for you. So if I start way over here and I connect smoothly, but not going very steeply, there's my cube root. It'll look like that. And you can see that it is also going up just like the square root does. It actually goes up even more slowly than the square root. And turns out the higher the root is, the more slowly this one is going to grow. Okay, so let's talk about domain. Domain is left to right, smallest to biggest on the x-axis. This arrow tells me it's going on and on forever left. This arrow tells me it's going on and on forever right. So our domain here, negative infinity to positive infinity, or all real numbers. All right, how about the range? Range is bottom to top. It's the smallest y value to the biggest y value. Well, this arrow, it does go left, but it also goes down. And this arrow, it does go right, but it also goes up. So the range then will be negative infinity to positive infinity, or all real numbers. And you guys can see both the x and the y intercept. It's right here at the point 0, 0. I could substitute in 0 up here and I could solve, but I'm going to end up with the origin for both my x and my y intercept, just like I did for square root of x. So if you think about it, this half is similar to square root of x. It's just a little bit flatter. And then this side is just going the opposite direction. It would be like if I took that and I spun it over here, it would end up kind of going down and to the left. All right, let's look at some of our key features of this one. So if I look at the intervals where this one is positive, what does positive mean? All right, positive means above the x-axis. So I'm going to color this part blue, put my arrow there, because that is above the x-axis. And negative, negative being the opposite of positive, that means below the x-axis. So I'm going to color this part red, arrow there on the end. Okay, so let's see what those intervals are. The interval for positive. You can see it starts being positive right here at the x-intercept, and it continues being positive forever because of that super messy arrow I've got right there. So the interval for positive, 0 to infinity. Okay, so based on what we said for square root, should we include 0 or not include 0? Well, we're not going to include 0 because the y value of 0 is 0, which is neither positive nor negative. All right, let's do our negative interval. So the negative interval is here. Remember, our intervals are always based on our x values, and they always go from left to right. So the furthest left that this one goes, where it actually starts being negative, is negative infinity. It's negative forever that way, and it stops being negative at 0. Okay, so what do you guys think? I didn't include 0 here. Does that mean that I should include 0 here? No. 0, the y value at 0 is 0, which is neither positive nor negative, so it is not included in either place. All right, how about increasing and decreasing? So remember, increasing means going up, decreasing means going down. And if I look at my graph, it's going to start increasing here, and it's going to keep increasing all the way. So what is my interval for increasing? Well, it's increasing everywhere on its whole domain from negative infinity to positive infinity. So what did I color orange? Where is it decreasing? Well, it's not decreasing anywhere. So the answer to that one is none. There are no intervals where this one is decreasing. All right, now just like before, let's look at those two together. X to the third and cube root of x are inverses of one another. They undo each other. So here's the green one. That's cube of x, which we looked at in a different video. Here's the red one, cube root of x, which we're looking at right now. And there's that diagonal line, y equals x. And you can see, just like before, the cube root of x and x cubed are mirror images of each other. You can see this part is mirrored right here in this part. And then the negative part of x cubed is mirrored right here in the negative part of cube root of x. So they are inverses, they are opposites, they are mirror images of one another across this line y equals x. And hopefully that's going to help you remember the shape, that they are just mirrors of one another across that diagonal line.